Hello, everyone. Welcome back to AI Tutorials, Machine Learning Tutorials. Today, we are going to talk about classification algorithm. How is classification used in different machine learning or in different applications? How we do it? What are the steps involved? Okay. And in the end, we will see an example of code in Python which uses classification to classify flowers, okay, using the iris dataset. So basically, what is classification? It's a supervised learning technique. What it means is when the training data, the model knows, you tell the model that what the training data is, okay, like whether this is how a spam email looks. So you will give an email, you will label it as spam. So then the algorithm will run like that. You will give multiple emails, and then each one will be spam. You will also give it emails which are not spam, so that it can correctly identify which one are the spam emails. So let's say if you need to classify flowers, you will give it all the flowers with its data, like okay, the petals are this size, the leaves are this size, the stem is this, the shape of the leaf is this, the petals are this big, and it is called as flower, say rose. Yeah, or if XYZ, it is called as sunflower. And then you give the unknown data. Based on the training data, it will try to predict what is the input category, or which category does the given unknown data belongs to. Okay, so the model learns the patterns that differentiate the categories. It uses this knowledge to classify new and unseen data. So you'll give it a list of all the spam emails and emails which are not considered as spam, and then so that becomes the training data. And then you will give it one new email that comes in, and you will ask it to classify whether it is spam or not spam. And depending upon the diversity of your training data, the output will be either right or wrong. So where is classifications used in AI? It's used in spam filtering, image recognitions, like whether this images of dog, cats, cars, flowers, whatever it is, fraud detections, okay, transactions that might be fraudulent, a sentiment analysis, whether the text is positive, negative, or neutral sentiment. What are the different algorithms which comes under classifications? They are decision trees, support vector machines, and k-nearest neighbors. Today, we are going to talk about k-nearest neighbors, or KNN. So this classifies data based on majority vote of its nearest neighbor. Let's see what does that mean. So KNN, which is nearest neighbors. So K, again, it's an algorithm, classification algorithm, right? Because it comes under that. It's one of the popular algorithms and straightforward approach for classification and regression problems. What is K? K is nothing but a number, which means, say, 5 or 10. So 10 nearest neighbors. Okay. So what it is, what are the steps involved? So first of all, you define K. Now, why do we need K? When input data comes in, the value the value that the algorithm predicts that this value is, now what should it classify as? So let's say 20. So what should be 20 classified as? So what it will do is and let's say your K is 5. So it will look at the 5 closest value which are there for 20. And whichever it is closest, it will vote that, okay, it will classify the given input as that value. Okay, so it's important, it's crucial step as it heavily influences the outcome. Like how many neighbors do you want to compute? The lower k leads to stable but potentially more accurate results. Less stable but more accurate results, while higher k, like Say, for example, you take 50 nearest neighbor, introduces stability, but it might lose accuracy due to the noise in the data. And then calculate the distance. What it means is, whatever the predicted output value, compute what is it. So let's say if k is 5. So it's what is its distance from each of the 5 nearest neighbors. So nearest neighbor, so let's say the output is 20. Its 5 nearest neighbors could be 21, 22, 15. Okay, so see, 15 goes a little far, 18, and say 21. So what is the distance with 20 from each of these? So once you have the k value, the algorithm computes the distance between the new data point, that is the one that you want to classify or predict, and all the points in the training data. And then identify its nearest neighbor based on the calculated distances. The algorithm identifies which are the 5 nearest points. Okay, point which are nearest to the output data, new data point. And these are considered as the nearest neighbors. Once that is identified, the algorithm identifies the point k nearest to the point, and these are considered as the nearest neighbor. And then what you do, classification, then majority vote. In classification problem, the algorithm assigns the class label that is the most frequent or the most nearest one. Okay, it's like a democratic vote within the neighborhood, that which one it is out of the 5. Let's say if k was 5, out of the 5, which is its closest to. Okay, and then you can even have weighted vote, or you can assign weights to the neighbors based on their distance, and then whichever has the highest vote wins it, which means it classifies it as that. Like whether it's a spam or not spam, it's a rose or a tulip, what it is. So let's see an example. This is a iris dataset example. So this is nothing but different varieties of this flower, iris flowers, and it's the input data. See the input, this is the input data. These are the attributes of the data. So length, width, petal width, if this is the values, what flower it is. If these are the values, what flower it is. If these are the values, what flower it is. So these are the labels, right? The categorical value and all numerical values with the data points. And these are the attributes. Let's see an example. So what you do, you use sklearn. You import the iris dataset. What you do, you train and split, import the necessary libraries, you load the data set, you give it X and Y. Y is the target, X is the data. You train the data, you split it, X and Y. You're giving the nearest, the K value is 5 in this, so it will compare it, the output value to the 5 nearest neighbors. Train the model, calling the fit method, then you predict. And then what you try to do is, so predict the new type of flower. So you give new numerical values and it will try to predict what type of flower the algorithm thinks it is. And if it is correct, you don't have to test with more data. But if it is wrong, you have to go back and retrain your data. Let's see this in actual example. Let's take an actual example in Jupyter Notebooks and see it. Okay, let me reshare my screen. So I am using online Jupyter Notebook here. So the code that we saw earlier, these are different cells. So go here, you load it, you import the libraries first, load the iris dataset, define the algorithm, KNN, train and fit the data. And when you run it, see, predicted flower type is Virginica. And if we go back to our slides, if we go back to our slides, okay, maybe I closed it, so I don't know. So let's say even if I change it to 6.4 and see what it does. It is still nearest is this, okay? Let's say if we change the value of k, what happens? Instead of 5, we make it 15 nearest neighbors. And then redo it. It is still same because the value is too big, that as we saw. All right, so this is how what classification is. Its usage we saw with an example. We have labeled data. We train our model with labeled data. We first importing the necessary libraries. We define the algorithm. We pick k, and then we try to predict. Okay. Have fun with the code. You'll find a lot more examples on the web and on GitHub. Okay, but this is how classification is in machine learning. Any questions, concerns, comments, please feel to write a comment on the video. I'll try to answer them. All right, thank you. See you all in the next lecture. Bye.